Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at another element in our flow control or control of flow of our code. Particularly, we're going to take a look at looping, and specifically, we're going to take a look at an introduction to for loops. This video is part of a larger series of videos associated with our fundamentals demo. So to begin with, what you want to do is you want to obtain a copy of this snip of code that I provided, or just take a second to do a screen capture and then type the code in for yourself. Basically, what we want to do is we want to bring our function prototype over and add it to our ever-growing list of function prototypes. And we also want to copy the code, including the comments, down to the end of our source file. Now, to begin with, just want to point out a couple of things here in this particular example. First and foremost, I've given you some documentation associated with the structure of a for loop, but I've also provided you with a little bit of a skeleton of a table that we're going to use, as well as some temporary variables. And then lastly, note that our function signature accepts no input arguments and returns no output arguments. So, to begin with for loops, the idea is that you would want to run code or a line of code or block of code 0 or more times. And the idea is that if you're thinking back to your if statements, you had a choice of running a line of code 0 or 1 time. And so basically, if you wanted to do the same operation multiple times, you would simply have to write a duplicate or triplicate call to a function, basically one line of code for every call to a function, or one line of code for every repetition of the operation that you want to do. And particularly as your program grows, that's not a very efficient way of going about doing things. So what we want to do in this set of videos is we want to take a look at ways to run your code, a line or even a block of code or a function, 0 or more times. And specifically what we're going to do is we're going to focus on that multiple times. And I'll come back to running it 0 times in just a second. But to begin with, let's take a look at the syntax. And so the syntax for a for loop is broken into 3 parts. There's the initialization expression, the loop repetition condition, and then the update expression. The initialization expression is where you want the loop to start. The loop repetition condition is the condition that must evaluate to true. And I'm putting this in quotes because there is no Boolean in the base C libraries, but rather that the condition itself must evaluate to true for the loop to run or to continue. And then the third part of it, or the update expression, is how you want the loop to increment, or as we're going to see, also decrement. In other words, how do you want the value that controls the behavior of the loop to change? So if you'll notice here in the syntax, it's surrounded by parentheses, and then a semicolon follows both the initialization expression as well as the loop repetition condition, but no semicolon follows the update expression. And you'll also notice that the inclusion of these curly braces. Now, you'll discover that there are a couple of different ways that you can write a for loop in C. I'm going to sort of give you a recipe that should always work. And so I'm going to encourage that you always use the curly braces following your for declaration. And so essentially what happens is any lines of code that are included inside of this for loop will run as many times as the for loop does. So in other words, if your initialization expression and your loop condition, loop repetition condition are such that it allows the for loop to continue to run, then this block of code will execute. So let's take a look at some examples. So to begin with, I've given us a couple of temporary variables. We're going to focus first on an index, and it's very common that you're going to use integers to leverage perhaps a vector or an array, hence the variable name index. We'll come back to the the vectors or arrays in just a little bit. Instead, what we're going to do is we're going to focus on how to use that index variable to increment the loop or decrement the loop and then do some sort of basic operation. We're also going to come back and take a look at how a double can be used. So the first thing that I'd like for you to do is I'd like for you just simply to make a copy of our nice little table template, because we will use it a couple of times. And then inside of our little table template here, we're going to write a for loop that basically will start at a specific value and continue until another value is reached. And then inside of that loop, we're simply going to do a simple mathematical expression. So to begin with, what we're going to do is we're going to initialize our index equal to 0. And we want to continue this loop until it reaches 9. So in this case, we're going to have it say less than or equal to 9. The idea is I actually want this one to run 10 times. And then I'm going to simply increment the index variable. And in this case, it's going to simply increment by 1. So it's index equal to index plus 1, or simply adding 1 to the value of the index. Now, inside of this for loop, we're going to keep this fairly straightforward. We're simply going to use a printf statement with the first placeholder being a %d or an integer that corresponds to the index. And then we're going to just tab over just a little bit roughly to line it up with the value column that I have. And I just want to do some operation here. So in this case, I want to do 2 times the index, which is also going to result in a %d followed by a new line. And so for those 2 placeholders, I'm going to have the index and then 2 times the index. So nothing too complicated here. Now, what we're also going to do is we're going to temporarily comment out this second table because we don't want to print any extra than what we absolutely have to. So in other words, we don't want to confuse ourselves here. So I'm going to go ahead and comment out this block of code. And you'll notice here, once again, before we run it, you'll see that I'm initializing my index inside of the for loop as opposed to initializing it earlier in the code. It's perfectly fine if you want to also initialize it up here, but with the for loop, the first step of your for loop is to initialize the increment variable, or the iterator variable rather. So the next thing that we got to do is we got to come up here to our main, and we've got to modify our if structure to accept a new command line argument. In this case, we have an else if, and you can simply copy and paste the code from above or use this as an opportunity to refresh your memory, that we're going to use our string compare I function to look at our argv square brackets 1. In other words, the first argument that comes after the executable. And then from there, we simply want to use the name of the function as the switch. And so if you want to refresh your memory on that, you can simply come up here to the prototypes, and you'll see that this is our for loops underscore 01, which I'm going to copy and then simply paste into my if else. All right, and then once again, if that argv square brackets 1 matches that switch, in other words, there is 0 differences, then in this particular case, what we want to do then is we simply want to make a call to our for loops demo. And if you'll notice here, I've accidentally snuck in an extra set of parentheses. There is no harm in that, but just to keep the code clear, I'm going to go ahead and get rid of it. At that point, then the only thing we want to do is to go ahead and augment our help. So what I'm going to do is I'm just going to borrow one of the earlier lines and simply change here. In this case, this is our for underscore loop underscore 01. And once again, not necessarily the best help in the world, but this does document what our switches are. So this is at least a start. So you definitely want to come back to that as well. So we'll go ahead and build it. We will launch our command line. We're going to cd, in this case, to my documents, courses, EE233, projects, and in this case, this is my fundamentals demo, my distribution, debug, and my MinGW directory. At this point, it would probably be a good idea for you to type in dir, verify that your fundamentals demo is there, and then make sure now to pass the appropriate switch. And so in this case, it's for loops underscore 01, and you'll see our nice table with the values lined up nicely. But more importantly, you'll notice that in the left column, my index goes from 0 up to 9. It stops running the for loop once it's reached 9. And in the second column is just simply the results of a basic operation, in other words, 2 times the index. Now, let's elaborate a little bit on this. As a matter of fact, let's go down to our for loop. One thing I'll do just for aesthetics sake is I'm going to add another new line there so we can sort of separate out our tables. And then what we want to do now is we want to take this opportunity to make another copy of our table and go ahead and uncomment out the first one. And in this example, what we want to do is we want to build another loop. This time we want to count from 9 down to 0. In other words, we want to do the same thing as we did earlier, but we're going to have a different starting point for the for loop as well as a different ending condition. And in this case, we're going to have a decrement and not an increment. So, seems complicated. The reality of it is it's just a matter of modifying the first example. So we have a for loop that starts off with index equal to 9. We want to have the condition continue until it reaches 0. So in this case, it's going to be essentially our index is going to be greater than or equal to 0. If we only had greater than, that means it would stop at 1. So in this case, greater than or equal to 0. And then the third step is going to be the index equal to, whoops, didn't mean to do that, didn't mean to grab my semicolon there. It's going to be index equal to index minus 1. Now, inside, it's actually going to be the exact same line that we had earlier. As a matter of fact, if you want to come up here and you can just simply borrow this code. And the idea here is, once again, in that first placeholder, we will simply print out the index. In the second placeholder, 2 times the index. I'm going to go ahead and save it. I'm going to build it. And we've got a successful build. Let's jump out here to our command line. We'll hit the up arrow so that we can rerun the exact same executable with the exact same switches. And you'll notice that now my next table starts off at an index of 9 and then counts down to 0. And the value, of course, in the second column is just simply 2 times the index. Now, we want to take a look at another example. This time, though, we want to use a different data type. We want to use the double data type and the current variable. And the idea is that with for loops, we aren't necessarily limited to using just indexes for our iterator variables. As a matter of fact, you're going to discover there are other possibilities as well besides numeric, especially in other languages. So to begin with, we're just going to go ahead and once again copy our table, uncomment it, and then while you're at it, go ahead and add a new line to the previous table just so that we have some delineation between the two. The first thing we want to do with the table itself is we want to go ahead and change the value or the column header, if you would, from index to current, because this time around our goal is to build a loop using a double, not an index, a double current rather than the index, which was an integer. And so to begin with, same process, we're going to start off with the for loop syntax. So we initialize the iterator variable. In this case, it's going to be current equal to 0.0 since it's a double. We're going to specify that our current continues until it reaches the value. In this case, I'm going to do something a little bit different. I'm going to have it be less than or equal to 2.0. And then to further emphasize an example of where you might want to do something different than an integer, we're going to have current equal to current plus 0.1. And so the idea here is I want to increment by 0.1. Now, to have something a little more interesting in our table here, rather than just 2 times the value, I'm going to go ahead and use a different function. So in the first placeholder, I still want to have my %.2f. And I'm going to carefully tab over. We'll see if we get this lined up correctly. We can always play with it. And then for the second value, since whenever we operate on a double, we should get a double back unless it's a specific function or that we cast it. We're also going to expect a %.2f followed by a new line. And then for the first value, I'm just going to simply put in the current variable. And then for the second value, I'm going to use the pow function. And I'm going to specify powers of 2. So in other words, pow, current, comma, and then sorry, let me rephrase that. I'm going to specify squaring the current value, not powers of the current value here. So, all right, so let's go ahead and build this. Let's go and run this a third time. You'll see that our table got a little bit longer here. Almost got it lined up correctly. As a matter of fact, we could take just a second and add an additional space there. But you'll see that my loop started off at 0 and then continued up to 1.9. And why did it stop at 1.9 and not 2? Was because we are dealing with doubles and we're dealing with precision related to doubles. So this we're going to cover later on when we look at the precision associated with the different data types. But in this case, basically what you have is a round off, essentially a round off error associated with adding, in this case, the 0.1 to the current value. So in other words, every time you add 0.1 to the current value, you don't get an exact value. In other words, it is not exactly 1.1 or 1.2, or in this case, 2.0. So when you make the comparison here of current to 2.0, there is the possibility that you would not end up with the value that you expect here. So we can talk about how we can handle this in a later video, but just be aware that there is going to be some issues with respect to dealing with doubles in your iteration variables. All right, but continuing on here, you'll notice that the value then is just simply the value of the current variable squared. All right, so this brings us to our last example of what happens when we write the for loop in such a way that it never runs, or more specifically, how would you accidentally write a for loop, or perhaps even intentionally, so that it runs 0 times. And what I'd like to do is I'd like to finally uncomment our final example here. And what I want to do now is I want to build a for loop using, once again, our index variable, but I'm going to intentionally write it as such that the for loop never executes. So to begin with, we can specify the index equal to perhaps 0. And then the idea here is that we have some sort of expression here that already evaluates to false. So in this case, a simple example of this would simply be while index less than 0, and then index equals to index plus 1. Now, in this particular example, if index starts off at 0, in other words, the initial value is 0, 0 is in fact not less than 0. It's actually less than or equal to 0. So in this case, what would happen would be that this for loop never runs. And so just to prove this, what we'll do is we'll once again borrow our code from an earlier example. Go ahead and build it once more. And we'll go ahead and run it. And you'll notice here that while I do get the table columns and the nice header there, I don't in fact actually get any values or any iterations of that for loop. And that's just simply because in this particular case, it was a poorly written condition, but there may be scenarios where you may be comparing it to another value, in which case you don't want the for loop to run at all. So we'll come back to that in just a little bit. We'll also have this discussion again when we're talking about the differences between for and while loops and why you would pick one or have a slight preference to one or the other. The last thing that I want to show you in this video before we leave is a shorthand notation that you've probably already seen in a textbook or perhaps seen in other online videos, as well as possibly even seen in my code. And so what I'd like to do is for just a second, I want to go back up to this first example. And I'd like to rewrite the increment, the way I'm incrementing my index variable. And so this line right here, we're going to go ahead and comment this out, and we're just simply going to rewrite this for loop. We're going to use the exact same initial condition, so nothing changes there. We're going to use the exact same ending condition. Once again, nothing changes there. And then for the increment, though, what I want to do is I want to use a shorthand notation of index plus plus. And so in this case, index plus plus increments by the value of 1. So what you're seeing on, in this case, line 475 and line 476 is, in fact, the same thing. It'll run the exact same number of times. As a matter of fact, just to prove it to yourself, go ahead and build it. And we'll go ahead and run it one more time, and we'll take a look now at that first table. Just scroll up just a little bit here, and you'll see that there was no change from our earlier example. So once again, hopefully you've found this video useful. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.